Hello there, and today we are trying to draw the free body diagrams for the real applications. So this is the one of the important topic in engineering mechanics. So in the series of lectures we have seen to identify the forces and to draw the reaction forces, one should have to complete the free body diagram. So again I am going to be trying to say what is the free body diagram. So there we can see, and we must understand before going to the free body diagram, we need to understand what is the constraints. Already we told the constraints is nothing but the restrictions we are imposing to the motion of a body, and so that we are trying to keep the body in the equilibrium condition. The next one, the types of supports and support reactions. It depends on the requirement that supports we need to design, and then we need to oppose the motion of the body. So in this case I am going to try to give one real example. For this one I would like to define what is the free body diagram. So the free body diagram means, to draw the free body diagram of a body, we remove all supports. All the supports here, wall, floor, hinge or any other contact body, and replace them by the reactions which these supports exert on the body. So in this case we are removing the wall, floor, hinge or any other contact body, and we are replacing with the reactions. So once it is going to be removed, this floor or hinge, automatically the body is going to be not getting the reaction forces and it is moving in the down. But we need to keep the body equilibrium conditions, then we need to apply the reaction forces. That's what we have seen so far, and we are trying to do the same kind of things here. So here I would like to take one practical example. A bus is on the road. So then in this case what will happen, the bus always we are using to the transportation or other purpose of the goods transportations also we are using. So the road is going to be, we are preparing with the hard materials, so that the reaction force is going to be generating from a road to the wheel is going to be in a good condition, so that we can move a little fast. So here I am going to give the one example. Assume that this is going to be the road and here the bus is going to be there. So there always there is a contact is establishing between the road as well as the bus is through the wheels. So there is a two-wheel drives are there, four-wheel drives are there, and more than wheels also we are using. For the depends on the load carrying capacity we are using. So in this case I have taken the one bus example. So the bus is going to be making a contact between the roads through the wheel. So once it is going to be see, the body is or in the backward direction. So then in this case what will happen, but we need to develop a free body diagram for the bus here. So then how to draw the free body diagram? As we told that first we need to remove the supports and then show with the reactions. So in this case the road I have taken and this is going to be the bus. So then what I am going to do, I am going to be remove the road, so where we are getting the reaction forces. If assume that if I am going to be remove the road here, so then because there is a support here is the road, so once it is removed, then automatically the body is going to be trying to move in the downward direction. So then it is very clear that the motion was gained in the vertically downward direction. But I want to keep the body in the vertical direction. That means in the same position. So then what I am going to do, I am going to be show with the reaction forces at the different tires, R1, R2, R3 and R4. So these are the reaction forces I am showing after removing the support, so that the body is going to be at the equilibrium condition. Means the self weight of the body is going to be, the self weight of the bus is moving in the downward direction, but the reaction forces are moving in the upward direction, so that the system is going to be in the equilibrium condition. And I would like to give one more example, that is going to be smart street light pole, or any pole you can take it over there. So then in this case what will happen? So this is going to be the street light. At the same time we do have the foundation, so that the system is going to be in the rest condition. That means the what are the forces are coming and it will transfer to the foundation. So then what will happen if I am going to remove the support? So then what is the condition for this pole? So then once if I am going to be remove the supports, so the pole is going to be trying to move in the downward direction, right? It is going to be falling, but I want to keep in the same position. So then what I want to do, first I want to find out the self weight of the system, and then I will show with the reaction forces vertically from the upward direction. So this way the body is going to be in the equilibrium condition, then automatically the pole is going to be in the same position. So in this case we are assuming that the motion is going to be existed vertically downward direction when I am going to remove the support. So once you are understand the motion of a body, and then we are applying the constraints to that motion is in terms of the reaction forces. So next I am going to be taking the books on a table. These are the general examples daily we can see in our life. So in this case we can see, so there is a table I kept, and then I had loaded with a bundle of books. So in this case what happened, always it is going to be subjected to the self weight. Assume that the table has enough strength to give the support to the books. So then if I am going to remove this table, how to draw the free body diagrams? So can you see here, that is the table and the books I have taken. Just I am removing the table, so then we can see the books are going to be trying to fall from there. This is also the expected in the vertically downward direction. So then what will happen in this case, I want to keep the body in the same condition, then I assume that the self weight is acting in vertically downward direction. And the next, the reaction force is going to be coming from the table, which is going to be opposing the motion of your body, and that going to be our constraint or the reaction forces we have generated. This way we need to assume the motion, and these are the parts. So now another example is the cup in hands. So here we can see how we are holding the cup. In this case, the cup is going to be in the round shape and the both hands we kept it. It means that the reaction forces are going to be generating on the body from the both hands. So then the body is going to be in the equilibrium condition. So here I'm going to be assuming first the motion of your body. If I'm going to remove the hands, then what will happen? So then that body is going to be fall from there and it is going to move in the downward direction. So then I want to show the reaction forces for this. I have a cup, right? And self weight is going to be acting vertically downward direction. And assume there's going to be a reaction forces from the both hands, that is the R2, as the R1 forces are going to be acting. Then the body is going to be in the equilibrium condition. So this way we are going to be draw the free body diagrams for the cup. So it means that the supporters is going to be the hands here, that we remove it and shown with the reaction forces where it can restrict the motion of your body. So in this case, what is the main outcome? So what we are learning? So in a series of video lectures we have seen, the mostly in mechanics is depends on the free body diagrams, right? What is the free body diagram? That the first we remove all the supports like floor, hinge or other contact bodies, then allow to the motion by assuming that motion is going to be in a respective direction, and then show the reaction forces in a particular direction so that the body is going to be in the equilibrium condition. Next, how to develop the constraints to the motion of your body. This is the part of this free body diagrams. First we need to understand the motion of the body, if you supports, and then show with the restrictions or the constraints to that one. Then the external forces already we have seen, and the internal forces. Sometimes these internal forces converted going to be the external forces. The next, practicing of free body diagrams for real time applications. There we can see the different types of applications we have seen. So similarly, you are going to be sitting in a chair, or you are writing with the pen, right? You are holding the books in your hand, or you are carrying the load at your shoulder or on your head. So these are all going to be the real examples. We can draw the free body diagrams for this. So here I would like to give the few examples here. So there one of the civil structure where the bridge is going to be using for the transportation from one point to the other point over here. So there we can see. So this is going to be, the bridge is going to be laid on the water body. So there we can see there is a one pillar is there, and the both directions the ropes are going to be connected, and that means they are going to be supporting with the ropes as well as the hard structure here. So can you draw the free body diagram for this? And similarly I would like to go with one more example. So that's going to be here, a human is going to be trying to do some kind of exercises. So in this case what will happen, the position is going to be here. Can you see that legs is going to be and the hands? So in this case he is trying to do the some kind of exercises. Can you draw the free body diagram for this one? So thank you. Please follow my series of video lectures so that the connection will going to be come to your mind. That means for better understanding you can follow my channel. So for more updates follow my channel. Thank you.